Okay, this stupid furnace. Yeah, this problem is amazing. It's pretty clear. So this is a follow-up, a repeat of my previous video, and I simplified the test a little bit, or the setup. So what I've done here is disconnected the feed wires to the solenoid for the gas valve. That's this black and white one here, and it's 24 volts AC. Instead of having it connected to the gas valve solenoid, I simply put a 12 volt pilot light bulb in there. Actually, it's an old dash light bulb, and I put a 180 ohm resistor in there to drop that voltage because it is 24 volts. And what this will do is this will visually show me when the controller module is commanding heat by energizing the gas valve. And what my theory is the gas valve is dropping out for some reason. Somehow the controller is dropping the signal to the solenoid as it's in this heating cycle, and it drops the flame, and it causes it to go into a full new reheat procedure with the hot surface igniter. So what I've done here is I have a 24 volt transformer AC that's plugged into the wall with a suicide plug, and that comes up here, and I have it just dummied in on the terminals of the gas valve where these two wires would be, this black and wherever they are here. So the black one and the yellow one will normally go to the solenoid. Now I'm actually got a surrogate, a donor 24 volts AC coming in here. And the way I control the gas valve, you got to be careful. There's a switch here. So this switch actually turns the solenoid on and turns the gas on. You have to be really careful because there's no safeguard when you do that. You'll be pumping raw gas up into the tubes. There's no flame. This is the flame sensor, what they call flame rectification. There's none of that. There's no limit switches. By doing this, you have bypassed everything. So that's the importance of watching the visual indication. So what we're going to do is turn it on, and it'll go through the heat cycle. And what you'll see is you'll see the hot surface igniter down there heat up for a long time until the computer thinks it gets hot enough. There's a temperature sensor back there for that. And then it'll close a relay down in that computer board, or controller, I guess, and it'll bring 24 volts down to the solenoid, which in our case is just going to light the light bulb. So what I'm going to do, as soon as I see that light bulb light, I'm going to reach here and flip the switch to turn the solenoid on. Because you can hear it. I'll turn it on real quick just for a second. Did you hear that? Be real careful because it's putting raw gas in there. So again, as soon as I see the light bulb turn on, that's when it's commanding the solenoid. So I'm going to manually turn the solenoid on. That'll get the flame going and start heating the house up. And then as it's running, we'll be able to watch this light bulb. And what I've noticed, you'll see it starting to flicker and get dim and half brightness. And at some points lately, it's been going out altogether. And it's crazy. I don't know what's causing it. The only thing I could think of, it's a set of relay contacts. There are 4 relays down in here. One to turn the venter motor on, one to turn the main blower motor on, one to fire the igniter, and then one, of course, for the gas valve. So my theory is the contacts in one of these relays are arcing. So, and you should see that with this light. So here we go. So we're going to turn the switch on. That energizes the furnace. The first part of the cycle is the venter motor running. It's purging any of the air, getting the fresh air up in there. So if there's any residual gas in there goes the hot surface igniter. And we're going to watch the light bulb right here. So as soon as the light bulb comes on, that means that the controller has commanded the solenoid to turn on, which it won't turn on because it's not connected to that. It's connected to my surrogate donor 24 volts AC. So I'm going to have to just visually flip the switch. The igniter's getting pretty hot. Light bulb is on. Then turn the switch. Close the solenoid, or energize the solenoid. The gas is on. The hot surface igniter is going down. And we're running. So I don't know how long it can run, but we're going to focus on this little light bulb here. And let's see. Last couple of times. There it is. See it? See that's flickering? Look at that. What in the heck is causing it? Look at it go out. Look, real dim. Up, back on, up, back on. That to me tells me that's mechanical relay points. And had that been connected to the solenoid, that'll drop out the solenoid, the gas will go off, it will trigger the flame sensor circuit, tell the computer to shut the gas valve off for good, and then restart a whole new cycle, energizing the hot surface igniter and retrying to open the gas solenoid. If it doesn't do that on a second time, it just locks out. It just sits there and lets the main blower run all night long, and it won't do any more heat. It won't try to restart it anymore. So it doesn't always do that. It's just really sporadic. The fact that it's not flickering on and off tells me it's not the computer controlling the relay. It's telling me the relay itself, the contacts are bad, or some sort of output circuitry, or maybe the transformer. There's a 24 volts in series with some set of relay contacts that the computer chip closes the coil, or energizes the coil, closes the contacts, which will put 24 volts AC up into the path of the solenoid. But you saw it, folks. You saw how that went dim and all that. That's not characteristic of a relay being turned on and off. That's characteristic of a bad mechanical joint or something else. So the house is freaking cold. So I've got the thermostat set way up. We're just going to let this run. Even if the light bulb goes out, we still have heat. I'll stay out here. I don't want to leave it unattended. That way I can just pull the plug and drop the gas valve if I have to. If something happens, I just reach in and turn the switch off. Can't imagine what will happen. In this bypass mode, I do not have flame detection, or what they call flame proofing, for the flame rectification circuit. Flame detector back there. It's just a stainless steel rod. That's all there's to it. I won't have that. So if the fire accidentally goes out, it won't have the ability to close the gas valve, or open the gas valve up, or close the gas valve. So open the relay and close the valve. None of the limit switches are going to work. That's an over temperature limit switch there. There's one over here. There's one for the firebox back there. Then there's what they call the flame out sensor right there. Got too much gas, or if the flue pipe is plugged up, flame can come back out and heat up the surface of that. And that's another circuit into the microprocessor controller that'll shut the gas valve off. So any or all of those conditions can shut the gas valve off, which won't happen in this bypass mode. The only way I could shut it off is either flip the switch, or I disconnect it here, or just reach over and pull that plug. So we're going to let it heat up. So that's pretty tough. See, now it's on. And every time I run this, it's different every time. That's the part I do not understand. You would think that if the relay contacts were bad, you would see them kind of arcing all the time. The time before this video, it went out, it went real dim and went out and never came back on. So you may see this blue dot in the video bouncing around here. I figured out what that is. It's a reflection from this light bulb on the lens of the iPhone, and that's what it is. So if you can see that blue dot, I can move it right on the light bulb. As soon as I move it off, it's like a little pointer. I noticed that last night. It's a little reflection. Just a weird quirk of the iPhone. So that's that. We'll sit and watch it. Drink my coffee. Sunday morning, Valentine's Day. Can't be with Valerie. It's too much snow out there. Last night I did tear the drywall out. I got that all tore out, cleaned up, vacuumed up. Ready to, I got this heater going because it's pretty cold out here in the garage. I'm ready to put this new piece of drywall in. I got it measured. I need to score and cut that. Cut that 1 foot off or so, or whatever that is. And then I have to measure for the outlet and cut a hole in there for the outlet. And then very carefully lift that up in there, get a couple of drywall screws, and then I can begin to tape this. I'll fire tape that. I pulled the old tape off. It can be a little bit of a chore, but it'll be okay. I got all the supplies there. I got some mud, the all-purpose. I like that real dense stuff. It's good for fire taping. It's real heavy and it's hard. When that stuff dries, it's concrete. It'll shrink, high shrinkage. It'll pull into the joint. It'll pull the tape backwards. I really like that stuff. That's the stuff on the right. Super heavy. The light is what you put on afterwards. Easier to work with, much easier to sand. High shrinkage, really good for bonding, good for cover coat. Tiki doesn't even sleep in that cat anymore, in that box anymore. So there we have it. So I don't know. I'm going to let the house heat up. I got a couple other things to do, and then I'm going to tear this thing down, tear that controller out, take it up in the electronics room handler. But I wanted to get hot enough in the house first, or warm enough that I could work comfortably. But see, sometimes this thing will run for minutes, sometimes it'll run for hours. But if you saw it flickering, that would have been enough to kick it out in the lockout, but being it's bypassed, it's okay now, so I don't know. So I'll go on my merry way and let this thing cook. See you guys later.